guys, Mrs. Dan's here. Sorry I couldn't be in class today, but I'm being trained. So we're starting a new book, and today's lesson is pretty basic. I'm hoping that you remember or were exposed to some stuff about square roots. If not, don't worry, I'm going to take it from the beginning. So you are going to do the do now, which is filling in the two tables at the top, and if you could just copy down the objective. I'm hoping that really I am just reminding you about a square root. And we're going to talk about rational and irrational numbers, which again you should have already been exposed to as well. So if you didn't get a chance to do the do now, I'll do it with you even. So we're just squaring numbers. That you've done before. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. I would hope that you know the squares of the numbers up to 12. And then if I square negative numbers, I also get a positive answer, right? Because this is really -1 in parentheses squared. Because it's asking me to square x. X is a -1. I'm squaring a -1, therefore my answer is a +1. Here, -2 should be placed in parentheses, and then we square it, therefore the answer is 4. So this one's 9, 16, and as you can tell, the answers are exactly the same as up above. Now this is important to notice because today we're going to be doing the square root of numbers. Square root is the opposite of squaring. So if it's the opposite, it means I'm going to start you off with the 25. I'm going to ask you what's the square root of 25. So you have to think opposite. What number squared is 25? Well, obviously there's two answers. -5 squared is a 25 and a +5 squared is a 25. So that's what we're in for today. And that's what this sentence tells us here about the square root of 16. The answer is 4 and -4. Now it's very important to know the symbol for a square root, which is this funky little division sign, but really it's called the principal square root, and that's so important to understand that a principal square root only means to give the positive answer. So if I use this symbol, so if I were to go down to this chart and ask you what this is, the answer is 2. It's not -2 because this is the principal square root, which means just give the positive answer. If I wanted the negative answer, then I would put a negative sign in front of that principal square root. So now I'm going to ask you what's the negative answer to the square root of 4, and you're going to tell me it's a -2. Finally, if I want both answers, because really there are two answers, always, all numbers have two square roots, I would put a plus and a minus sign in front. So I'm asking you for both the positive and the negative square root of 4, and the answer is +2 and -2. So we should be able to fill in this chart pretty quickly, even just by using the chart up above. The square root of 1 is 1, and I only want the positive. The negative square root of 1 is a -1, and then both answers. You can write it as even set notation 1 and -1, or you can write it what I wrote over here using that plus and minus sign, one above itself. So this chart now needs to be filled in. Now this last one, you should easily be able to do it. If I put a square root sign over 4/5, 4/25, I'm sorry. We're trying to think of some number that you multiply by itself that would give me over 25. Wouldn't that be 2/5? 2/5 times 2/5 is 4/25. So remember, square root is the opposite of squaring. Think of some number that if I squared it, if I multiplied it by itself, would get me the answer of 4/25. Some people like to say that instead of putting a big fraction, a big square root sign over a fraction, they like to say you could take the square root of the top number and the square root of the bottom number. That's true too, right? So it does turn out to be 2/5. This one's a negative 2/5, and this is a positive and a negative 2/5. So there you go. That's how you do square roots. Now, the one thing that we have to talk about is what you've done in the past. Rational numbers are numbers that can be written in the form of a over b, where a and b are integers. And I should also point out that b can't be 0 because then it would make this undefined, right? So denominators can never be a 0. Irrational numbers cannot be written as a over b. Where a and b are integers. A radical, that's another name for this symbol. So we could call it the principal square root. We could also call it a radical. And a perfect square are these list of numbers that we did up above. These are perfect squares because it's a whole number times itself. Perfect squares are nice because they're easy to take the square root of. I know that the square root of 9 is 3 because 9 was perfect. If I ask you what's the square root of 10, like I could squeeze it in here, I guess it's between 3 and 4. It's not like exactly 3.5. Obviously, you could see that this square root 10 must be closer to the 9 than it is to the 16. Therefore, the square root of 10 is closer to 3 than it is to 4. Is it 3.1? Is it 3.2? Honestly, it's an irrational number, which means its decimal part is actually non-terminating and non-repeating. The square root of 10 is irrational. It cannot be written in the form of a over b. And if it can't be written in this fraction form, that means that its decimal part is one of those crazy decimals that go on forever and never repeat. So we could actually go back to this rational and irrational and just discuss what the decimal looks like. The decimal of rational numbers are either terminating or repeating, because something like 1/3, I'm going to put some notes a little at the bottom here, 1/3 is rational because, first of all, it's written in the form of a over b, but also we know that its decimal form is a repeating decimal. It's 0.3 repeating, where something like pi is irrational. It can't be written in the form of a over b because its decimal form is non-terminating and non-repeating. So that's why it's nice to know you list the perfect squares. A perfect square means that it's comes from an integer being squared. It's the list at our do now, the do now list. And I have to tell you, of course, it goes on forever. I could square 13, I could square 14, and so on. So its list comes from an integer being squared. I'll say an integer squared equals a perfect square. I'm not going to worry about this right now. I'll tell you that all repeating decimals can be written as fraction, but when I'm in class, I'll show that to you. And I now want you to do that separate paper with the people at your table. It's just telling me whether it's rational or irrational, telling me how you know, and then telling me its value. And that's that. So the square root of 25, principal square root of 25, the value is 5. Therefore, it's rational. And my reasoning is because it can be written in the form of a over b. I'll say it can be written as 5 over 1, right? So it can be written as a fraction. Something like the square root of 50 is now irrational. This number 50 never appears on our list of perfect squares. That's something you want to look back at to determine whether it's rational or irrational. The square root of perfect squares are always rational. The square root of a non-perfect square is always irrational. So here's 49, which means 50 comes right after it. 50 is somewhere between these two perfect squares. So if I try and take the square root of 50, it's a crazy decimal. So that's why it's irrational. It can't be written as a over b. Something else I want to definitely say is that it's because it's the square root of a non-perfect square. If you use your calculator, it will tell you approximately what it is, but I can kind of think about it in my head. I know the square root of 49 is 7, so this is a little bigger than 7. It's definitely smaller than 8, because 8 times 8 is 64. I don't know, is it about 7.1 maybe? Take a look on your calculator. Square root of 50. It rounds to 7.1, so it's good that I said it's about 7.1. So the calculator, my calculator, displays this. If you use your graphing calculator, you might be able to fit more digits, so you'll see a little bit more. If you would use other different types of calculators, the calculator screen displays different number of digits, because depending on how large the screen is, which really just proves that this number does go on forever. I don't see anything repeating. It's going to keep on going, therefore it's irrational. So if you can finish this with the people at your table, and then when you finish this, you could start your homework. Your homework are these 2 pages finishing this chart. So really you're telling me whether things are rational or irrational and how come. And you're telling me its value, and you can round to like the nearest 10th, unless these directions say something different. Let's take a look. Round to the nearest 100th. So that's it. It wasn't too bad of a lesson. You could do this without me. I'll see you tomorrow. Bye.